So now we'll see about the rotor part of the synchronous generator. So in rotor there are mainly two types. So first one we'll see, that is silent pole type of rotor, and second one is non-silent pole of rotor. So first we'll see the silent pole of rotor. So in this type of rotor, it is used low and medium speed of the alternatives. It's a speed of 300 to 600 RPM. This type of rotor has large number of projecting poles having their cores bolted to the heavy magnetic wheel of a cast iron or steel. You can see there in figure. So there are number of poles which are attached to the core part. Okay. Such rotors have large diameters and short axial length. The poles are laminated to reduce the eddy current losses. Coils are wound on these poles, and when a DC supply is given to the coils, the poles becomes electromagnetics. The DC voltage required to excite the pole coils is obtained from the pilot exciter, which is fixed on the shaft of the alternator itself. The DC voltage is fed to the field coils through two carbon brushes, which slides on two slip rings. The alternator with this type of routes are usually engine driven and rotates on the horizontal axis. So this is all about the silent pole of a rotor. So now we'll see the non-silent pole or smooth cylindrical type of rotor. This type of rotor usually drive by turbines and rotates very high speed at 1500 to 3000 RPM. Basically, this kind of rotors are used for the high speed motors, and the silent poles are basically used for the low speed of motors. So the rotor consists of steel lamination which are insulated from each other and pressed together to form a cylindrical core having a number of slots on the outer periphery. For the accommodating the field winding, such a rotor is designed to have 2 or 4 poles. It usually rotates on the vertical axis, and it's characterized by small diameter and large axial length. 2 or 4 regions corresponding to the central poles area are left unslotted, and these areas are surrounded by the field windings placed in the slots. The field coils are so arranged around these polar areas such that the flux density is